Okay, so 8.6 is going to be scale factors. Now we've kind of done this already. Remember how we've had k is equal to, not moving, model over actual. And we've had k squared is equal to area of the model over area actual. Now we're just doing k cubed. And what do you think k cubed would be? Yeah, so the difference now is it's going to be volume. Model over volume actual. Okay, so what you gotta do for the first one is it says find the volume of each. So find the volume of like 1 cube. And if you're not sure how to like use this graph paper, they kind of show you how to make like a cube down here. So go ahead and do that and fill out 1 to 8 there and answer, if you can, answer this question. So if you need a hand getting going, I'll kind of show you what I mean. So 1 cube, you can kind of see would look like, that's one side of it, that's the top of my cube, that's the back. So that would be cube of 1 unit. So now we just want to make 2 units, 3, 4, 6, and 8. So we should have 8 cubes on your sheet. Okay, so you guys should have got these numbers for your volume. So you can kind of see it. As we double, you can kind of think about, well, if we double, then that's going to be 2 times 2 times 2. We're increasing it by a factor of 8. If you triple, you're going 3 times 3 times 3, right? Because it's volume, length times width times height. You get 27, and then the same with the other ones. So that's that. Here's our new formula that we're using for this unit. Okay. This one says, consider the below Rubik's cube. Suppose the area of one of the colored faces is 1 centimeter squared. So like this is 1 centimeter squared. Determine the area of the left Rubik's cube. So how would you figure out the area? And then multiply it by 6, right? Yeah. Yeah, so all we gotta do is just count the squares on this side for the first one. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's gonna be 9 for the surface area of this one side. 9 times 6. Oh, 6. Which is something or other? Yeah, 54. So 54 centimeters squared for this Rubik's cube. Part B says using scale constant, so k value for area. What is the area of the right Rubik's cube? Verify by actually determining the surface area of the right cube. So all we got to do for this one, for surface area, so you can see that this one was 1, 2, 3 long. This one is 1, 2, 3, 4, 5, 6 long. So what would the k value for this be? Which one? We're saying the model's like the new one. Yeah. So we're like scaling it up. So model over actual. Yeah, so k in this. So just looking at the one length of this thing, it's just going to be 6 over 3. So k is going to be equal to 2. So scale factor is 2. Okay, so we're dealing with area though. So it says we're looking for the area of this thing. our formula for area is k squared. So k squared is going to be area of model over area of actual. So k squared is going to be equal to, the model is the thing we don't know, so we'll call that x, over the area of the original one was 54. Okay, and we know what k squared is too, right? That's 2. So 2 squared is equal to x over 54. If we rearrange this by multiplying both sides by 54, so 54 multiplied by 54, those cancel, and I've got, let's write it up here, x is equal to 54 times 2 squared is 4. So x is equal to 216 centimeters squared. Does that make sense, Tim? Yep. So now it's the new part. Find the volume of both Rubik's cubes. What's the scale factor with scaling volumes? So all we have to do now, the first one we have to actually just find the volume by counting. So we're going to go 3 times 3 times 3. So the volume of the first one is 27. And centimeters cubed. So if I want to find the other one now though, I know it's going to be our formula is k cubed now for volume is equal to volume of model over volume actual. And I know what k is. K was equal to 2. That's the same for no matter what we're talking about here. So k is going to be 2 cubed is equal to volume of the model is what we're looking for, so we'll call that x, over volume of the actual, that's the one we just found here, so 27. So if you rearrange this, x is equal to 27 times 2 cubed is 8. So x is equal to 216 centimeters cubed. Okay, there is actually a question, or a couple questions pretty similar to this one in your guys' exam too. Are you guys doing okay? Okay, so for this one, it says the Great Pyramid of Giza is shown below. It has a square base of side lengths 230.4, vertical height of that, and a slant height of that. So if I place the measurements on here, the base of this thing from there, next one's to there, 230.4, so it's 230.4 there, and 230.4 there. We've got the slant height. Slant height is just a height from there to there, right? Like going up the face of the thing. The slant height is going to be 186.4. And then the vertical height of this thing, like this, is going to be 146.6. Okay. So the question says, an artist wants to make a glass replica of the pyramid. The floor space she has to work with is 6 by 6. So if I kind of start filling in what I know here, this is going to be 6. This is going to be 6. So right at the bat, I got two numbers I can compare. I can compare this to that.
Yeah.
And if I do that, I can get a K value, right?
Yeah, but I don't know if it's right. 0.02.
Okay, so you went the little one over the big one?
Yeah.
Okay, so that would be right, yeah, because the model's gonna, this is going to be our model. So if we want to find our K value, we'd say K is equal to model over actual. We don't, here the model is 6. The actual pyramid was 230.4.
Oh, you're trying to factor this model?
So K is equal to, what did you say, 0.02? 02?
Yeah.
Okay. The smart board's so shady.
Oh, wait.
I feel like that's new. Okay, so we got our K value. Now what we gotta do is, now that we know the K value, we can rewrite all the rest of the measurements too. So on this pyramid, we also have slant height. How can we figure out what that is now that we know our K value? So yeah, K is equal to model over actual. So let's just figure out what the model, I know what the K value is at 0.02. So my model I don't know. And the actual, we're looking at 186.4. So it's just going to be 0.2 or 0.02 times 186.4. So our slant height coming up here is going to be 3.7.
Or you could factor it out.
So if I'm going to figure out my height now, I'm just going to do the same thing. So we're going to say that's 0.02 for my K value is equal to X over 146.6, which, so X is equal to 46.6 times 0.02. 2.9. So this is going to be 2.9. Okay, so B says how much glass will she need for the 4 faces. So this is just a surface area problem. So it just wants to find the surface area of the 4 faces, right? So surface area, how do you find surface area?
6 times 6. No, oh, the sides. So
Yeah, we just want the sides. So we've just got 4 triangles, really. We've got to find the area. So area of a triangle is base times height divided by 2. And then we have 4 of them, so it's going to be times 4. So base, so it's going to be equal to 6 times the slant height, right? Not the height of our pyramid. I want the height going up the face of the triangle. So 3.7 divided by 2 times 4. So that's equal to, yeah, 44.4. Where are we in centimeters? Meters. Meters cubed. Square. Sorry, surface area. Okay, this one, the smaller tank in the photograph, so this one, has a capacity of 1,400 meters cubed, larger 4725 meters cubed. Both are being filled at the same time. How many times longer will it take to fill the larger tank? So if you saw these two numbers and someone said how many times bigger is the big one, what would you do to figure that out? Yeah, you just divide them. That's so straight up. We just go divided by. And you can think about this as like model over actual. same thing. We're just saying how many times bigger it is. So if I said how many times bigger is it? 47. All right. 3.4. So K in this case would be 3.4. And it says how many times longer will it take to fill? If it's 3.4 times bigger, it's going to take 3.4 times as long to fill too. So how many times greater is the radius of the larger tank? Okay, so if this is my sphere, remember that radius, the sphere is in 3 dimensions, but the radius is just like one line, right? So just like what we've done before, we've got a K value of 3.4. So it's just going to be 3.4 is equal to model up top, actual on the bottom. We said the model was the bigger one in this case, so that was 47. Okay, so we're running out of time though, but what you have to do is we're still going to have model over actual, but what we got to do is figure out the radius of the smaller tank here using volume is equal to 4/3 pi r cubed. Sorry, you could do it that way, but the other way that we could do it is we know that to get 3.4, we had to go like that would be the K value cubed, right? To get 3.4. So all we gotta do is take a cube root of that, of 3.4, and that's gonna tell me the radius. Does that make sense though? Yeah. Okay. Okay, so that's all we have time to do. So can you guys go ahead and do the rest of the questions on that? And I'll see you in class.